Hello Kickstarter, my name is Damien and over the past 6 months I've been developing MicroPython, a lean and fast implementation of the Python language, optimized to run on a microcontroller. I have a background in computer engineering and theoretical physics, and in my spare time I like to build robots. I use Python on my PC every day, and had the idea that I could also use Python to control a robot. The difficulty with putting Python on a microcontroller is that it uses a lot of memory and doesn't allow low-level access to the hardware. I rewrote Python from scratch, aiming to address these problems at each stage of the design and implementation. At its core, MicroPython is a compact Python compiler and runtime environment that uses memory very efficiently. It has 3 ways of compiling functions depending on desired speed, memory use and functionality, and also includes an inline assembler. MicroPython allows you to write real-time low-level drivers to control lights, LCD displays, motors and other things, whilst also being expressive and powerful, allowing you to easily write high-level code for the brains of a robot. While developing MicroPython, I also designed and built a small microcontroller board on which MicroPython can run. Python is a very popular language with a vast existing community and a heap of reusable code. Most people find Python extremely easy to learn, and advanced users choose it for its power and expressiveness. For the board that I developed to run MicroPython, I needed it to be small enough to fit inside a tiny robot, but also have enough features to be useful. The board measures 40 by 33 millimeters, has an ARM CPU, USB connector, buttons, LEDs, and a micro SD card slot. Also, a 3-axis accelerometer, voltage regulator, and 30 input-output pins. These features on their own can already be used for many different things, such as logging data and controlling servo motors. You can connect the board to many existing devices, or even design your own board and put MicroPython on it. MicroPython can run with or without a PC. When connected to a PC via a USB cable, it acts just like a USB flash drive. You can copy your Python scripts across as you normally would, and when the board reboots, it runs them. Programming for MicroPython requires no software except a text editor. Any text editor will do, and works on Linux, Windows and Mac without any setup. A simple thing you can do is to use the accelerometer to log the motion of the board to a file. With this Python script, the board will write to a file the X, Y and Z values of the accelerometer, and the output will look something like this. MicroPython also acts as a USB serial device, giving you a standard Python command line running directly on the board. You simply open up a terminal emulator and start typing Python commands straight to the board. This is a great way to test your ideas and debug your code. Here we are running Conway's Game of Life, written in Python and drawing to the connected LCD display. Due to the efficient use of memory in MicroPython, in this example no heap memory is allocated and no garbage collection needs to run. Here we load a bitmap from the onboard flash file system and draw it to the LCD in real time. The MicroPython board has hardware floating point, and here we are using Python's complex numbers to generate the Mandelbrot fractal. Here we have a small robot, and we are using 2 of the accelerometer axes to control the robot's servo motors. There is no connection to a PC. Here we have the MicroPython board connected to a Bluetooth module, a battery and 2 servo motors. We can connect over the serial Bluetooth device and have a remote Python command line. The MicroPython board can also act as a USB mouse and even a keyboard. This is selectable in the configuration file which runs on boot up. Python functions can be called on an interrupt. Here we are generating a sound signal using the digital to analog converter and amplifying it into a speaker. Full details on the MicroPython compiler and how the inline assembler works can be found in the project description. Through Kickstarter, I wanted to share with you my passion for robotics and programming. I thought many of you would be excited to be part of the development of MicroPython and also own a MicroPython board. MicroPython is currently running very well, but there is still some work to do. With your support and involvement, I can continue to develop MicroPython, extend its functionality, and make it free open source software. I need enough people to pledge for a MicroPython board so I can do a small manufacturing run here in the UK. I will also make the board open hardware. So, come on Kickstarter, get behind MicroPython, get yourself a MicroPython board, and be among the first to experiment with the smallest Python ever made. Thanks for watching.